Myself, Jamuna, second year MSc student, thus in Computer Science, Manasa Gangotri, University of Mysore. I am going to present Bayes theorem and Navy Bayes classifier. Bayes theorem. It describes the probability of occurrence of an event related to any condition. It is also considered for the case of conditional probability. Bayes theorem is also known as the formula for the probability of causes. For example, if we have to calculate the probability of taking a blue ball from a second bag out of three different bags of balls, where each bag contains three different colors balls red, blue, black. In this case, the probability of occurrence of an event is calculated depending on other condition is known as conditional probability. Table of contents, statement, proof, formula, derivation, examples, Navy Bayes classifier algorithm, working of Navy Bayes classifier, example problems, advantages and disadvantages, applications. Bayes theorem statement. Let E1, E2, En be a set of events associated with a sample space S, where all the events E1, E2, En have non-zero probability of occurrence and they form a partition of S. Let A be any event associated with S. Then according to Bayes theorem, P of Ei by A is equal to P of Ei into P of A by Ei divided by summation k is equal to 1 to n P of Ek into P of A by Ek for k is equal to 1 to 3 up to n. Bayes theorem proof. According to the conditional probability formula, P of Ei by A is equal to P of Ei intersection A divided by P of A. This is called equation 1. Using the multiplication rule of probability, P of Ei intersection A is equal to P of Ei divided by P of A by Ei. This is called equation 2. Using the total probability theorem, P of A is equal to summation k is equal to 1 to n P of Ek into P of A by Ek. This is called equation 3. Putting the values from the equation 2 and 3 in equation 1, we get P of Ei by A is equal to P of Ei into P of A by Ei divided by summation k is equal to 1 to n P of Ek into P of A by Ek. The following terminologies are also used when the Bayes theorems applied. Hypothesis. These events E1, E2, En is called a hypothesis. Priori probability. The probability P of Ei is considered as the priori probability of hypothesis Ei. Posteriori probability. The probability P of Ei by A is considered as the posteriori probability of hypothesis Ei. Bayes theorem formula. If A and B are two events, then the formula for Bayes theorem is given by P of A by B is equal to P of A intersection B divided by P of B, where P of A by B is the probability of condition when event A is occurring while event B has already occurred. P of A intersection B is the probability of event A and B. P of B is the probability of event B. Bayes theorem derivation. Bayes theorem can be derived for the events and random variables separately using the definition of conditional probability and density. From the definition of conditional probability, Bayes theorem can be derived for events as given below. P of A by B is equal to P of A intersection B divided by P of B, where P of B is not equal to 0. P of B by A is equal to P of B intersection A divided by P of A, where P of A is not equal to 0. Here, the joint probability P of A intersection B of both events A and B being true, such that P of B intersection A is equal to P of A intersection B. P of A intersection B is equal to P of A by B into P of B is equal to P of B by A into P of A. P of A by B is equal to P of B by A into P of A divided by P of B, where P of B is not equal to 0. Similarly, from the definition of conditional density, Bayes' theorem can be derived for two continuous random variables, namely x and y, as given below. F of x by y is equal to y of x is equal to f of x comma y of x comma y divided by f of y of y. F of y by x is equal to x of y is equal to f of x comma y of x comma y divided by f of x of x. Therefore, f of x by y is equal to y of x is equal to f of y by x is equal to x of y f of x divided by f of y. Example and solutions. Some illustrations will improve the understanding the concept. Example, a bag contains 4 white and 6 black balls, while another bag too contains 4 white and 3 black balls. One bag is drawn at random from one of the bag and it is found to black. Find the probability that is was drawn from bag 1. Solution. Let E1 be the event of choosing the bag 1, E2 the event of choosing the bag 2, and event of drawing a black ball. Then P of E1 is equal to P of E2 is equal to 1 by 2. Also, P of A by E1 is equal to P of drawing a black ball from the bag 1 is equal to 6 by 10 is equal to 3 by 5. P of A by E2 is equal to P of drawing a black ball from bag 2 is equal to 3 by 7. By using Bayes' theorem, the probability of drawing a black ball from bag 1 out of 2 bags P of E1 by A equal to P of E1 into P of A by E1 divided by P of E1 into P of A by E1 plus P of E2 into P of A by E2. Substitute all the values in this equation. 1 by 2 into 3 by 5 divided by 1 by 2 into 3 by 5 plus 1 by 2 into 3 by 7. Solution is 3 by 12. 7 by 12. Naive-Bayes classifier algorithm. Naive-Bayes classifier algorithm is a supervised learning algorithm which is based on Bayes' theorem and used for solving classification problems. It is mainly used in text classification that includes a high-dimensional training dataset. Naive-Bayes classifier is one of the simple and most effective classification algorithms which helps in building the fast machine learning models that can make quick predictions. It is a probabilistic classifier, which means it is predict on the basis of the probability of an object. Some popular example of Naive-Bayes algorithms are spam filtration, sentimental analysis, and classification articles. Working of Naive-Bayes classifier. Working of Naive-Bayes classifier can be understood with the help of the below example. Suppose we have a data set of weather condition and corresponding target variable play. So using this data set, we need to decide that whether we should play or not on a particular day according to the weather condition. So to solve this problem, we need to follow below the step. First step, converting the given data set into frequency tables. Second step, generate likelihood table by finding the probabilities of given features. Last step, now use Bayes' theorem to calculate the posteriori probability. Problem. If weather is sunny, then the player should play or not. Solution. To solve this, first consider the below data set. This is the data set table. Second step is generate likelihood table by finding the probabilities of given feature. Frequency table for weather condition. This is the weather condition frequency table. Likelihood table for weather condition. The final step is applying Bayes' theorem. P of S by Sunny is equal to P of Sunny by S into P of S by Sunny. P of Sunny divided by S is equal to 3 by 10 is equal to 3 by 10 is equal to 0 0.3. P of Sunny is equal to 0 0.35. P of S is equal to 0 0.71. So P of S by Sunny is equal to 0 0.3 into 0 0.71 divided by 0 0.35 is equal to 0 0.60. P of no by Sunny is equal to P of Sunny divided by no into P of no divided by P of Sunny. P of Sunny divided by no is equal to 2 by 4 is equal to 0 0.5. P of no is equal to 0 0.29. P of Sunny is equal to 0 0.35. So P of no by Sunny is equal to 0 0.5 into 0 0.29 divided by 0 0.35 is equal to 4.1. 0.41. So, as we can see from the above calculation that P of S by Sunny greater than P of No by Sunny. Hence, on a sunny day, players can play the game. Advantages and disadvantages. Navy Bayes is one of the fast and easy algorithm to predict a class of dataset. It can be used for binary as well as multi-class classification. It performs well in multi-class prediction as compared to the other algorithm. Navy Bayes assumes that all features are independent or unrelated. So it cannot learn the relationship between features, advantages and disadvantages. Applications. It is used for credit scoring. It is used in medical data classification. It can be used in real-time predictions because Navy-based classifier is an eager learner. It is used in text classification such as spam filtering and sentiment analysis.